Summary measures. Coefficient of variation. Next, we have the coefficient of variation, which is a measure of relative dispersion. By definition, it is unitless. A summary measure used to compare the scatter of one distribution with the scatter of another distribution. What do we mean by unitless? When you calculate the coefficient of variation, it does not have a unit of measurement, because it will be expressed as a percentage. Formula-wise, we have the population coefficient of variation CV is the population standard deviation divided by the mean multiplied by 100. So let us dissect again the formula. Why do we say that the coefficient of variation is unitless? Because the population standard deviation carried the unit of our observations, and the same with the mean, it does carry the unit of the measurement of our observations. So, for example, if our standard deviation is in kilograms, and the mean is also in kilograms, the unit of measurement cancels out. And the fact that you multiply it by 100 makes it a percentage, and leaves the CV unitless. For the sample CV, there is not much difference in its formula. It still uses the standard deviation and the mean. But of course, we have different formula in computing the sample standard deviation. So, when do we usually use the CV? Let us have an example in the next slide. Here is an example scenario. Let us say I want to visit 3 countries: France, Japan, and Belgium. But my savings will allow me to visit just one of the 3 countries. My goal now is to determine which country will maximize my money in the exchange rate. In France, the currency is in franc, yen in Japan, and euro in Belgium. What will I do now to know which country will allow me to maximize my money when I travel? I need to know which currency is more variable. And to do that, I will be getting the mean and standard deviation of the currency exchanges of the 3 countries. Then I will compute for the CV. What am I trying to say here? The 3 datasets now have 3 different units of measurement, and automatically, their means will be different from each other. So, if I want to compare these 3 datasets with respect to which is variable, I don't need to convert their units of currency to Philippine peso. Instead, I just need to compute and compare their CVs. Let's say I got a CV of 10% in France, 20% in Japan, and 30% in Belgium. As mentioned, the higher the CV, the more variable the dataset is. Then, where will I go to maximize my money? Looking at the computed CV, the answer is now easy in France, with a CV of 10%. Because the currency is not a variable, so I can maximize my money. And because the currency is not a variable, I can plan my travel easily. I can go ahead and exchange my peso in franc anytime without having to worry about exchange rate issues. Let us have another example. Suppose you have 2 options in buying a stock. Stock 1 is currently priced at 2,000 per share, and stock 2 is priced at 550 per share. In buying stocks, risk is reduced by choosing a stock with stable price. However, there are instances where you could take a chance on a stock that grows greater variation in price, hoping that the prices go up rather than go down. A sample of price of stock 1 and stock 2 were collected at the close of trading for the past months. Now, which stock are you going to select? Basically, this example is trying to tell us that there are 2 types of investors who buy the stocks. One is the risk-averse or conservative, and the other one is the aggressive. A conservative investor will choose the stock that is less variable or with a stable price, while an aggressive investor prefers more variable stock prices so they can wait until the prices go down as low as possible to buy the stocks. And then they will wait for the prices to go up, and that's when they sell. In the blue box, we have the mean price and the standard deviation of the stock prices. Notice how stock 1 and stock 2 have the same unit of measurements. Then, why not just compare the mean and standard deviation? Since we have different means, we cannot outright say that the standard deviation for stock 1 is more or less variable than stock 2. Instead, we can use the CV. Going back, our goal is to choose a stock. So, we will go ahead and get the CV to compare their variability. Logging in the values for stock 1, we will get a CV of 29.3%, while the computed CV for stock 2 is 15%. Given the CV, we say that the stock 1 price is more variable than the stock 2 price. Again, if you are someone who is into stocks investment, which will you choose? And the answer is it depends on which type of investor you are. If you are a conservative investor, you are going to choose stock 2 with a smaller percentage. Its price is less variable. While if you are the risk type, or the aggressive investor, you will definitely choose stock 1. Here are some things to note about the CV. First, the higher the CV, the more variable it is. And second, there is no uniform cutoff for the CV, but some statisticians or researchers use the 20% cutoff point, especially when dealing with sampling designs. Whenever the PSA selects a particular sampling design in estimating their indicators, they select the sampling design with the least CV in the estimation. Usually, if the CV is greater than 20%, then they opt not to use it. To summarize, in any data analysis, the most commonly used statistics to complement the measures of central tendency in describing our data are the following: range, standard deviation, and the coefficient of variation.